Welcome to 5G Hub. Today we will talk about 5G coverage study on C-band. So the first question is what is C-band? The C-band is the range frequency between 3.3 to 4.2 and 4.4 to 5 gigahertz and is allocated to mobile service on a co-primary basis in almost all countries throughout the world. Administrations will make the available different portions of 3.5 gigahertz range at different times and building large contiguous blocks incrementally. The availability of at least 100 MHz channel bandwidth per 5G network with the adoption of massive MIMO will post peak average and still edge throughput with affordable complexity. In line with the release plans from many countries, the 3.5 or 3.3 to 3.8 megahertz band will be the primary 5G band with greatest potential for global harmonization over time. But what about the coverage status of the C-band for 5G? Compared to lower frequency bands such that 1.8 GHz, 3.5 GHz presents some coverage challenges as higher frequencies lead to lower signal propagation. This can be compensated for by using massive MIMO antennas, which can provide higher beamforming gains compared to typical passive antennas at 1.8 GHz because 5G coverage is in uplink is limited. So what about uplink coverage? So as shown in the figure, the C-band uplink and downlink coverage differs by 16.2 dB from field test. However, using massive MIMO technology, the C-band downlink can achieve the similar coverage as the LTE 1.8 GHz, but there is a limitation in the uplink coverage and becomes 5G deployment bottleneck, which will affect the user experience. So, what about uplink coverage for 3.5 gigahertz band? This is the question. 3GP Release 15 introduced two mechanisms to handle the limited uplink coverage on the higher bands, namely one, new radio carrier aggregation and supplementary uplink using uplink and downlink decoupling. So the question now, how uplink and downlink decoupling works. Based on the supplementary uplink, the feature uplink and downlink decoupling defines the new paired spectrum, where C-band is used in the downlink, and this figure, for example, okay, where the C-band is used for downlink and sub 3 gigahertz, for example, 1.8 gigahertz for the uplink. This will improve the uplink coverage, and field tests show that combining downlink on C-band with uplink on sub 3 gigahertz can improve uplink and downlink experience by 6 times. Thank you for watching and see you in next video.